Every year, thousands of young people participate in local science fairs. Many of them go on to become successful innovators and entrepreneurs. Innovation and entrepreneurship are key to tackling global threats confronting humanity. And these young scientists and engineers are motivated to make a positive impact on the world around them. Alumni of the International Science and Engineering Fair have taken on exceptional challenges, launching breakthrough companies, becoming technology leaders, and disruptors. The Innovation and Entrepreneurship Panel, launched in 2017, highlights the ways in which these alumni are bringing their ideas to market, collaborating across industries, and changing the ways we look at science and the world.
Welcome, everyone, to the Regeneron International Science and Engineering Fair Innovation and Entrepreneurship Panel. I am Maya Ajmera, President and CEO of the Society for Science and publisher of Science News. Did you know that the Society for Science founded ISEF in 1950? I think back to our leaders who were visionary in founding the most prestigious STEM competition in the world. Today, you will learn from other visionaries, our alumni, and learn that innovation doesn't stop at ISEF. Our alumni are disruptors and they are launching companies. This year has shown us that we live in a rapidly changing world, and it's up to all of us to find new solutions to our ever-evolving challenges. As we look ahead to the urgent challenges and breathtaking possibilities of this century, we invite everyone to understand and engage in science and engineering that is transforming our world. I am so thrilled to be here today with four incredibly impressive alumni who are leading entrepreneurs. Our first panelist is Omar Abudaya, who is a McGovern Institute Fellow at the McGovern Institute for Brain Research at MIT. He attended MIT for his undergraduate studies and then Harvard Medical School and the Harvard-MIT Health Sciences and Technology program. And he completed his PhD in the lab of Dr. Feng Zhang at the Broad Institute of MIT and Harvard. FYI, Dr. Zhang is an ISEF alum too. Omar is a co-founder of Sherlock Biosciences that is providing a new set of tools for knocking down genes, visualizing transcripts, and making precise edits in RNA and mammalian cells with potential for RNA therapeutics. He is an ISEF 2008 alum. I'm pleased to introduce David Schlesinger, who is CEO and co-founder of Mendellix, a company dedicated to interpreting genomic information that identifies the cause of genetic diseases. Since co-founding the company in 2012, Mendellix has become the largest clinical genomics lab in Latin America. In 2014, David was awarded the MIT Innovators Under 35 for Abracadabra, an AI-based genetic variant interpretation algorithm. David obtained his MD and PhD in genetics from Universidad de Sao Paulo and is a board-certified clinical neurologist. David is a 1997 ISEF alum. Welcome, David. Our third panelist is Eden Fulgo. She is founder and CEO of Mobot, a mobile app testing service powered by robots. Previously, she invented the Sun Saluter, a low-cost mechanism that optimizes solar panels while providing clean water for rural off-grid communities in 18 countries. Eden was named a 30 under 30 in Forbes Energy Industry 3 years ago. She studied mechanical engineering, computer science, and robotics, intelligent systems at Princeton University. She is a Thiel Fellow. Eden competed in ISEF in 2007 and 2008. Our next panelist, Michael Lee, is the founder and president of the Data Incubator, a data science training and placement firm. Michael bootstrapped the company and navigated it to a successful sale to the Pragmatic Institute. Previously, he headed monetization data science at Foursquare and has worked at numerous companies, including Google, Andreessen Horowitz, JP Morgan, and D.E. Shaw. He's a regular contributor to many media outlets, including the Wall Street Journal, Wired, and Fast Company. Michael received his undergraduate and PhDs at Princeton and a Marshall Scholar in Cambridge. He's a 2003 ISEF alum. Welcome to each of you, and it's such an honor and pleasure to have you back and speaking to us today. So I'm going to start with, how's everyone doing? How are you guys doing in this crazy year and 2 or 3 months that we've been living in? Let me start, David, with you because you are in Brazil,
Yes.
in Sao Paulo. How is it? How are you doing?
It's been a roller coaster ride. Highs and lows. We've had a few waves, just like the United States, in different times. Every month, there's something big, different. Politics coming into it, the anti-science, which is a major problem. But all in all, Brazil is now getting into line, and I think I'm very optimistic about the second semester of this year.
How about you, Omar?
Yeah, it's definitely been a challenge to, I guess, maintain research. And, I actually started my lab at MIT a couple of years ago. So the pandemic kind of hit early on when we were trying to recruit people. And we actually had a bunch of postdocs and master students have to push back, they're joining 6 to 12 months. So the year has come with challenges, but it's also, I think, with sort of my background and sort of research and diagnostics, it's also been sort of gratifying to be able to contribute towards COVID testing and try to make a difference in that way. So, yeah.
How about you, Eden?
Yeah, the last year has been probably the hardest year of my career, of my whole life. So Mobot is a 16-person seed stage startup, and I think before COVID hit, I didn't recognize the magnitude of what it means to be feeding 16 families and supporting their livelihoods. And we're building these robots, and we're all in person in an office. And all of a sudden, with maybe a month's notice, we had to practice working remotely. How do you build mechanical robots remotely? It was pretty hard. We had to place, hardware store orders online and coordinate shipping parts back and forth to each other and retrain all of our employees on using the company VPN and making sure we had enough runway. We actually didn't, and had to raise a seed extension and finding investors. Thankfully, our existing investors doubled down on the company, and we were able to raise a seed extension there. But that wrangling that whole thing was quite the adventure.
Wow. And Michael?
Well, I actually had it pretty easy. We were New Yorkers up until recently, but then we moved to Seattle, where there's a lot more green, a lot more outdoor space. So it's been relatively easy for us, and I'm very thankful that we're here.
Wonderful. So I want to talk a little bit about the world that we're living in right now. Innovation is often coming together to solve a problem or answer a question. What challenges are you witnessing inside or outside your industry that you're eager to tackle? I'm going to start with Omar.
Sure. Yeah. I guess one easy place to talk is around COVID testing and diagnostics. I think I've been working in the CRISPR space for nucleic acid testing now for 4 or 5 years. And I think, we recognize that, bringing kind of the vision of, devices to every person's home, where you could sort of in real time test if you have a cold or pneumonia or something more serious could be really valuable for people. But I don't think, diagnostics has necessarily gotten the type of investment and attention as therapeutics and gene editing and drug development has gotten. But I think the pandemic has really acutely sharpened our attention that it is important to have cheap, rapid testing to be able to keep people safe. And I think that has been actually quite useful for accelerating progress in the field. And I think now the challenge is really trying to actually scale and bring this to everyone as soon as possible. I think we've seen universities and other workplaces bring more expensive testing like qPCR testing and other things to people, but a lot of places around the world don't have access to those types of more complex systems. So I think now the challenge really is to realize the vision of CRISPR testing and other technologies to bring them to everyone.
So I'm going to bring it to you, David, and your company and what you're doing in Brazil and Latin America.
So our main focus has been for the last 9 years in rare diseases and bringing the advances of whole genome sequencing and whole exome sequencing to Latin American countries throughout, from Mexico down to Uruguay and Brazil. But what has been very, brought to our attention recently due to the pandemic was how dependent we are in a full supply network, a worldwide supply network, and how this has multiple points of failure in a moment like this. So one of the things that we did in the pandemic was to create a new saliva-based COVID test here for Brazil. And we've tested almost 1 million tests already and growing. And making this ultra cheap so that it's accessible, in a continental country like Brazil is a real challenge. But this is still the focus. Pandemic brings everything to focus really quickly.
How about you, Michael?
Well, I think that one of the big challenges that the pandemic has brought about is the need to work remotely. And I think it's something that we've actually been fairly fortunate on. Our team has actually always been working across several cities. We've had intercollaborations even when we weren't in the same office. And that's actually kind of given us a bit of a leg up because we are so much in the cloud and we are so used to working across time zones and across geographies. So we've been quite fortunate in that regard.
Michael, let me ask you something. Can you explain what Data Incubator is quickly?
Yeah, sure. So we do data science training and placement. So we help people learn how to become data scientists and then get jobs as data scientists.
That's why you're able to work remotely and work online. Wonderful.
Yes, that's right. Nothing physical in the lab.
Nothing physical in the lab. Okay, Eden, how about you?
Yeah, so we've seen with the pandemic, people are turning to their phones more and more. They're more mobile. And even before the pandemic, over the last few years, people are moving away from clicking around in a web app, in a web browser with your mouse. Nowadays, you're on the go. It's so easy to develop new hardware, new wearables that are connecting to your phone via Bluetooth. And with all of this these products being developed, it requires physical testing. You have to test this product to make sure it actually works, especially if it's a medical device. You have to do all this verification and validation. And Mobot, we use a robotic fleet to automate testing for our customers. And so we've actually seen during the pandemic, people are still making mobile apps and physical products from home. So we have to be readily available to support them.
So I want to go back to your high school days, to ISEF. And you've got thousands of people watching you right now, but nearly 2,000 finalists. What did ISEF mean to you back then? And how did that lead you in the pathway of where you are today? Michael, I'm going to start with you first.
Yeah, so I actually attended ISEF twice, once in Cleveland, once in Kentucky. And I remember it was just this really amazing time where you get to meet students from all over the world who were equally passionate about science and engineering. And I think that was kind of a unique time, certainly the first time when I was growing up that I found other like-minded folks like that. And I thought it was a really terrific experience.
How about you, David?
Well, I think that the part of the experience that was really special was raising the ceiling, seeing how much higher the ceiling could be for passionate high schoolers just producing things that were unthinkable to me. And this was something that over the many years later, I am still impressed by such a high quality of work that high schoolers can produce. And thinking of what they can produce later in life is really cool.
Omar?
Yeah, I found, so I went to ISEF in 2008 and I found the experience exhilarating. It was, I came from a small town, Kalamazoo, in Michigan. And so I think going to ISEF and just being surrounded by thousands of other people doing like really amazing creative projects really sort of empowered me to feel like, if you can just, think of something, you can like go and pursue it. And I think I also felt really challenged by the people around me, which I found really awesome. The person next to me had like a binder of like hundreds of protocols protocols. And I was like, wow, you keep like notes of all your assays and protocols and like develop them and improve them. And like those concepts are just things I'd never like, heard of or experienced before. And now as like a seasoned scientist, I think those are, things you do. But for me, it was like the first time seeing all sorts of new things. And I think the second thing for me was, it was really a kind of a lifelong experience. A lot of the people who are like their posters were near me or people I met are still friends today. And some of them are even collaborators of mine. And it's people I met, more than 12 years ago now. And I think that's really cool. So.
How about you, Eden?
I think ISEF was the first time that, kind of like what David said, you got to see where the ceiling really was and how innovation in other parts of the world, other STEM projects, what the diversity of work that was being done. Before this, I had competed in science fairs locally since 5th grade. And some years I won, some years I didn't, but towards the end, of course, to get to ISEF, you're winning locally, you're winning nationally, and then you get selected. I'm from Canada, so I got selected as a part of the Canadian delegation. And this is a huge deal. This was very prestigious. And I had all this hype going into ISEF 2007 and 2008. And in both years, I actually didn't win any awards. And you can imagine at that award ceremony, everyone else's names, all my friends were getting all called up on stage. And I was just sitting here in the audience being like, oh, wow, I had no idea what I walked into. And I think that lit a fire in me that has really shaped the rest of my career. So for anyone else who may not be winning an award at ISEF this year, know that your journey does not end here.
Absolutely. That is great advice. Absolutely. So one of the things I'm famous for are my rapid questions. And so I've got one. What do you like, pancakes or waffles? Eden.
Waffles.
Michael.
Waffles.
Omar.
100% waffles.
David.
I'll say pancakes, contrary.
Wow. This is the first panel I've seen more waffles than pancakes. Very interesting. So I think a lot of finalists are wondering, where do I go from here, from ISEF? What would you say to them? Michael.
Well, I think it's a really, there's just so much out there to do. And I think you've just seen a sample of it, as some of my colleagues have said. And I just encourage folks to continue on and do science research in college, continue on that path of really kind of applying and using the scientific method, especially if you're interested in innovation and entrepreneurship. I think these are places where that kind of curiosity and that adherence to the scientific method and kind of rigorously following it is going to be invaluable as you enter the world of business and entrepreneurship. So just keep it up. It's good training.
How about you, David?
I'd say people can go anywhere. Just take your time. The real problems in the world one of them will bother you, and then you'll want to solve that problem eventually. And so, take your time to figure it out. And you don't have to rush things and go into entrepreneurship right out of high school. You can wait a while.
Eden?
I agree a lot with what David said. Don't let yourself be pigeonholed by the ISEF category you chose for your project. If you did a project in biotech, it's totally okay to choose engineering as your major in college. And even the major you picked in college, it's okay to change careers after that. You can have many shots at opportunities as you grow in your career. So definitely don't pigeonhole yourself, but use ISEF as an opportunity to meet others, explore different areas of research that you're interested in.
Omar?
Yeah, I mean, I think I'd echo what a lot of the other panelists are saying. I mean, keep going. I went to MIT, I guess 4 or 5 months after my ISEF experience, and I emailed like dozens of different professors. And, I think it's hard when you're starting out and don't have as much research background to get into labs, but, I'd say just keep trying to, pursue different things you find exciting. And, I went into mechanical engineering after studying medicinal leeches in undergrad. So like I pivoted a lot. I realized after a few years, I didn't enjoy enjoy biomaterials and MECI as much. So then I pivoted to nanotech and cancer, and then eventually molecular biology and molecular engineering. So I think paths can be very very flowing and kind of a random walk, and just enjoy the process. And the other thing I would add is also, try to stay in touch with people. Some of my closest friends at MIT were people I had met as a senior in high school at ISEF, and we had like a little group, and we'd get together and just talk about exciting research or just hang out. And those are the people I'm still in touch with today. So savor those connections.
Great advice. So now I'm going to do really particular questions to each of you, if you don't mind. Michael, you founded Data Incubator. What led you from where you were at Google and D.E. Shaw? What led you to see the need for building a company as you did?
Yeah, so I think I saw a lot of inefficiencies about the hiring process in data science from both sides of the interviewing table, right? Both as at an earlier time, kind of PhD trying to enter the industry, and then on the other side of that, as a hiring manager trying to hire people coming out of schools and trying to find people who would make good data scientists. And I just wanted to sort of build a program that could kind of help solve that.
Wonderful. Eden, you are about a pivot, right? You founded a nonprofit, SunSaluter, but then you went into the technology sector and have created a for-profit company. You're one of the Y Combinator graduates. Tell us about pivoting.
Yeah, so I think a lot of the experiences I developed building SunSaluter, the nonprofit, really actually translated to building a for-profit company as well with Mobot. Learning how to hire, learning how to fire, how to have awkward conversations, how to rally a team, and how to be that cheerleader when maybe you didn't have the sales or the community development projects that you wanted, but how do you kind of keep everyone together and focused on a core mission? I think a lot of those skills do translate directly. And for me, I stumbled into building SunSaluter as a nonprofit because it came out of my ISEF research. And I kept working on it throughout college and kept getting opportunities, kept getting grants. So I just kept working on it. And after a while, I was traveling a lot. I had to go to India to hold all these community development workshops. We had actually built out a whole team in India. And I am an introverted homebody. So as I, grew older and kind of realized what I wanted for myself personally and wanted to settle down and start a family, I met my wife and moved to New York. It kind of I realized that I'd like to try something else. And SunSaluter, we still had volunteers and other team members who were involved. And maybe after being the founder of that organization for 10 years, it made sense to start something new.
That's great. And so, David, I want to ask you. You are in Brazil. You founded your company. I suspect starting a company in Brazil has its similarities and differences from the U.S. perspective. Can you tell us what it was like founding your company and trying to go after venture capital in Brazil or government agencies? I'm very curious about that. And I'm sure our audiences, because nearly 40% of them are outside the United States.
It was wild. So it first making the decision to leave, I had a private neurology practice and I was doing research in a top hospital here in Brazil. And, I had 2 young kids, and making this decision to make this leap was pretty hard. But the opportunity that presented itself with the technology and everything that was happening in genomics 10 years ago was so big that we felt that it was more than necessary to do that. And if it doesn't work out, I can go back and we can go back. But the money, VCs in Brazil were not very common 10 years ago. Now the world is flooded with liquidity, and so I think it's much easier to raise an initial round, and the rounds are much larger, and technology is closer, cloud and other things, that you can create a company with a lot less money, but it was still hard. It was still tough. But it's not tougher than the US or India or China. It's just different.
It's different. Okay, Omar, you're in the field of gene editing. The whole CRISPR sort of movement, as they say. But there have also been bigger philosophical questions at play, like playing God. Do you and your colleagues ever find yourself asking the philosophical questions along the scientific ones when you talk about aging or early detection of disease? Just curious about that, about the intersection of philosophy with science.
It definitely comes up, and it's especially around dinner conversations with colleagues and other friends who are curious. But yeah, I mean, I think the big thing is the concept of where the ethical and moral dilemmas come into play, like around like designer babies and trying to like control intelligence or looks or whatnot, are so far off in the future. And there are so many current diseases, like there's thousands of diseases caused by basic genetic mutations or Mendelian disease, that even the current generation of CRISPR technologies and CRISPR companies are barely touching the surface of, right? Because you start a company, you can only go after, a number of diseases. It's not going to be able to target all 5,000 diseases and all the variants of those diseases. And so, even though I think, you have to consider what those moral implications are, I think we also have a duty to still like push ahead as fast as possible to alleviate that human suffering from those diseases. And I think, the idea of designer babies, which is I think the biggest moral dilemma of all, is I think people have to appreciate we don't have the knowledge yet to actually do a lot of the things you might want to do, right? Intelligence is a really complex question. Even looks and height are complex genetics, and we barely understand how those, how mutations and variations in humans, result in those more in those phenotypes. So I think until we understand those things better, those things really are far off in the future and futuristic. But it's something we have to consider. Yeah.
Okay, another rapid question. How do you clear your head quickly? David.
Reading.
Omar.
Marvel movies.
Eden.
I play Pokemon.
Michael.
I ride my bike.
Wonderful. Okay, we are now going to go into questions from our finalists. Our first question is from Jimosola Balogun in Nigeria.
Can you please cite instances of challenges you faced during your research work and how you overcame them?
Omar, I'm going to ask you to answer this question.
A good question. It's also a really tough one to grapple with, because I think, probably 99% of the things I do in a day or trying for a project are failing. And I think, getting used to constant failure and enjoying the few successes when, an idea works or, a technology actually results in good data is really important. But I think the key for me is, coming from an engineering background, is to tinker as much as possible and basically throw the kitchen sink of ideas at the wall. And so, when I'm at the end of a week, like literally this morning, I was like, wow, everything we tried last week, did not work. I think we sit down and we brainstorm for a few hours. We write down all the ideas. We do mind maps, right? This concept where you draw all the problems on the board and try to think systematically about like every way you can tackle them, I think is really important. And that design and engineering mentality works really well in biology, because biology is complex, but you can still try to predict and model and come up with solutions. And I think keeping a level head and working through things systematically is the way to go. So, yeah.
And our next question is from India.
The path from innovation to entrepreneurship seems to be a difficult one, especially if the innovator is from high school. How should such a student manage this journey to becoming an entrepreneur? Thank you.
Michael, I'm going to ask you to take that one on.
Yeah, I mean, I think that's really interesting. And I guess I would say, you don't have to take the thing that you invented in ISEF or what you did research on as an undergrad, or what you did research on as a master's student, or what you did research on as a PhD, and do that for your business. In fact, none of the things I did in my academic life have been things that I've actually tried to commercialize as an entrepreneur. So I guess I'd say, when you do go out and want to start a company, you do have to really think a lot about this whole other set of considerations, right? It's not just the science and the merits of the science and how cool it is, but it's also markets and what customers want and what customers need, and whether there'll be a demand for it. And I think you often find that the really hard problems that you worked on in research were incidental to developing a product, and that oftentimes it's really applying sort of good baseline techniques that weren't that hard, where the science isn't necessarily that hard to solve, but that kind of just work, and using that to solve an important pressing business or consumer problem.
Okay, this is a question that I'd like to pose to David. It's from Sanam Anagalat from Ghana.
When you first started out, did you have a fear of failure, a fear of blacking out at the most important moments? And if you did, how did you handle it?
Pathologically, no, I did not have that fear. It was more sort of a carelessness about it. It was, overconfidence for many moments. But it's also hard when you fail that way, or harder actually. So I would say, the failures that we have as high schoolers and as undergrads and graduate students are not that important. So go ahead, do them. Don't be fearful. It's not irreversible. You can always start over.
Eden, I have a question for you from Pravalika Pulatpatu from Virginia in the United States. She asks, how did you make the decision to apply for the Thiel Fellowship rather than pursue a traditional college experience? And do you think you made the right choice? And explain what the Thiel Fellowship is for the audience.
So in 2011, Peter Thiel had this idea to create a fellowship program for college students to drop out of their degrees, or not even just drop out, just take 2 years leave of absence to pursue a project or a startup or a business that they really felt compelled to work on full time. So in many ways, it's very similar to like a research fellowship. You're focused on a specific idea, and it means that you have conviction in this and you want the brain space, the time, the resources, the mentorship to go after that 100%. And so in my mind, there was not really, it wasn't all or nothing. I know I wasn't like picking college or no college forever. It was just for the next 2 years, did I feel strongly enough about the sun saluter idea and this solar panel passive rotator technology that I developed that I wanted to research it further and try to commercialize it. And so during my Thiel Fellowship, that was how I discovered, actually, it wasn't easy to commercialize a technology like that, but there were a lot of people around the world who could benefit from it. And so that's why I started a nonprofit. And I always knew I could go back to college after. I just ultimately decided not to, because I ended up stumbling into the tech industry and starting my other company.
Omar, I have a question for you from Raid Kabir in Mississippi in the United States.
I have a question specifically for Dr. Abudaye, and I was wondering, what pushed you to pursue an MD PhD, and do you ever plan to go back to Harvard Medical School to finish that degree? I know you've already become a prominent researcher otherwise.
So the question is, do you want to go back to med school?
Very common question I get, especially from my parents and other family member and friends. But yeah, I guess, growing up, or not even growing up, towards the end of high school and early college, I had always been focused on research and engineering, but I also had this attraction towards biology and the complexity of biology and treating disease. And so when I stumbled upon the concept of, you don't have to choose, you can, treat disease, but also research it. The indecisive nature of my personality was like, of course I'll do an MD PhD. Who cares if it's my entire 20s? And so, I entered the Harvard MD PhD program with the full intent to be a physician scientist, practice 20% of the time, run a research lab 80% of the time. But then after doing 2 years of medical school, and then starting my PhD at MIT in Fung's lab, I got swept into this crazy CRISPR craze that happened. It was an amazing time, just like, applying Cas enzymes for gene editing, discovering all these new enzymes and all the technologies we built. And it was just really exhilarating and hard to leave it. So I ended up staying an extra year to do more research. And then, we were starting a company on our CRISPR diagnostic work, Sherlock Biosciences, and the clock was ticking on my leave of absence. You have to, you only have a couple of years, and it was just untenable for me to go back. I was having a ton of fun. MIT offered me a position to be a fellow to start a lab with a close colleague of mine who we run the lab jointly. And now, we're starting to spin out other companies for some other technologies in our group. And it's just, I think once you choose a path and, you're having fun, it's hard to imagine doing anything else. And I think, at the end of the day, I really do want to help treat disease. And I've realized, I think still through, biotech and research and building these types of technologies, I think you can do that. It might take a longer time because, you do the research and then maybe you spin out a company and then there's a 5 to 10 year drug development, timeline. But, if I'm having fun and enjoying it, why do something else? So, yeah.
Thank you. David, I have a question for you from Ken Yaguchi in Texas.
I understand that Mendelix works with the analysis of genome sequencing. What are your predictions in terms of the innovations for this field throughout the next decade? Thank you very much.
Wow. So cost is going to continue to go down significantly. We're going to sequence more and closer to patients, closer to the environment. Smaller sequencers are going to produce more. I'm also very excited about the sequencers being intelligent so that we're going to be doing real-time sequencing and choosing what we sequence and what we don't. And I think protein sequencing in this next decade is going to be amazing. And it's going to revolutionize medicine again, just like genomics did over the past 10 years.
Our next question is from Aiden Pasinski in Utah.
If you could go back in time, before you became involved with your current company, and give your younger self any advice, what would that advice be? Thank you.
And I'm going to ask each of you this question because I think it's really interesting. So, Michael.
Yeah, I guess it's really be bold. I think there is kind of this apprehension, especially when, and I suspect this will be true for a lot of the ISEF finalists. You're on this sort of treadmill of success where you go to the next prestigious school, you do the next prestigious thing, you go to the next prestigious company. And, starting a company is this sort of like alternative track that's perhaps high risk and seems very scary. And I guess what I would say is be bold, right? Don't be afraid to jump off that treadmill and go do something that you're truly passionate about.
How about you, Eden?
I wish I learned how to work hard earlier. That sounds kind of bad to say, but I feel like high school, getting good grades, like some of that stuff kind of happened naturally for me. So I never developed this muscle on like how to go to the gym when you don't want to, how to really, push and study for a test when you don't want to, how to grind through hard things, difficult conversations with customers, difficult conversations with employees and team members. I had to learn to do a lot of that when I was older. And I think cultivating those habits younger, and it starts with self-discipline, it starts with sort of your personal productivity, those habits will really accelerate your life later on. And I feel like I had to kind of relearn a lot of that throughout my 20s. And so I wish I had done it, in my teens.
How about you, Omar?
Yeah, I think it's a good question. I think one of the things is probably like to understand that I think the most important thing is probably the people you work with and can recruit to work with you. I think growing up, I always thought, oh, a company, it's all about like a crazy, innovative idea that no one's thought about and like, will totally change the world. And I think now, being much older and seeing, the reality, I think, most good ideas, there's probably going to be people working on them. And if there isn't, the minute you have that idea and start working on it, probably other people will start working on it. And so it's I think less about the idea, more about, just being inspired by people you work with, people who push you, who challenge you, and, you doing the same to them, because that's how you really, test good ideas and develop better ideas. And I think also having kind of the vision and ability to inspire other people to sort of join your vision and your team. Because I think, a company is really about how the people are and how motivated they are to build towards a specific vision. So
how about you, David?
I think really big. Every time somebody throughout my life told me, you're limiting yourself or the company or this project, put a 0 on this and, increase it by an order of magnitude. That's when the best ideas and the best execution came out. So not limiting yourself to more conservative projects is a plus.
Great answers. Okay, next question is from Kushi Parekh in Arizona.
Unconventional ideas are traditionally met with opposition and resistance. So my question for the panel is, would you be able to provide an example of how you were able to overcome opposition and continue promoting your unique product or research? Thank you.
Is there anyone who'd like to take that on?
Sure, Dave? I can. Go ahead, Eden.
Eden, go ahead.
Sure. So in starting Mobot, we do mobile application testing in a dramatically different way. Most software engineers, you run your mobile app in a cloud-based emulator or simulator, and you automate that test, and then you're just like, okay, it's good to go. I can send it out to the App Store and Google Play, and now it's done. But how many times have we as consumers encountered some kind of software defect or bug using an app? And a memory leak, a crash, you use the camera, you can't connect Bluetooth. These are all physical usage that can't be emulated in a computer. And so we take an approach using mechanical robots to do that testing. And every single time I tell people this, they're like, is this a joke? Is this a gimmick? Like, you really have robots tapping on phones? That's actually your business? And I'm like, yes, we actually believe that is a faster, more accurate, more efficient way to test. But it's so different than the world of software engineering. And that's probably why nobody has ever tried to solve the problem this way. People in their own areas of research and discipline are so used to tackling the same problem with the same approach. And we are taking a completely different approach that combines mechanical engineering with software engineering. And definitely I get some weird looks, but you have to push through it, especially with the case studies and customers that are showing that your solution, your idea is working. Then you have some proof and you can start to share that with others.
David?
Well, I think, going back to the early beginnings of Mendelix, where we wanted to, I was seeing patients who had rare genetic diseases and they couldn't get genetic testing, not because it wasn't available in Brazil or because it wasn't available anywhere, because there's a very long tail of rare diseases that the labs at the time were not helping and didn't worry about. And so our idea was, let's do exome sequencing. Let's sequence everything that we can, and through software, reduce that to the diagnosis. And at the time, everybody said, this is not going to work. Brazil is a poor country. It's a developing country. You're going to put into the market the most expensive test that we can have for genetics. And it's actually what simplified the whole process and allowed us to scale. And so that was one of the instances where being a contrarian was a good thing. It's not always a good thing. A lot of the mistakes are also, and it's hard being a contrarian, and when everybody tells you you're gonna do something that's wrong, and it turns out that it is wrong. Everybody tells you, "Oh, I told you so," but it's part of life.
My next question is from Alan Zhang in Hong Kong. what are some of the most effective brainstorming techniques, and how can educational institutions promote innovative thinking? Michael, I'm going to hand that one to you.
Oh, that's a really good question. I guess that's sort of a two-part answer to that. The first is like, I think there is some amount of something that comes from intuition, and I couldn't tell you exactly what that is, but somehow I walk around and ideas come to my mind. And that's great, but ideas are a dime a dozen. And so the second part of that is sort of validating that and and testing it in the real world. I think at least what I've seen a lot is people really like to sort of sit around and talk about their ideas and kind of verbally like joust with them and talk to other people and have other people say, oh, no, that'll never work. Oh, no, this is a great idea. And it's like, that's nice, but in general, that's sort of not super relevant. What you really need to do is see if you're an innovator or an entrepreneur, you want to see if like people will buy your idea. And that's really sort of goes down to sort of talking to customers and seeing like, hey, what problems do you have? What pain points do you feel? And sort of getting that kind of immediate market testing, I find that to be the most useful way of validating ideas and also generating new ones.
Amar, I have a question for you.
Dr. Abudaye, what processes did you take in the development of the new CRISPR technology, Sherlock? How do you see the process of identifying genetic signatures associated with cancer being used to lead to improvements in the cancer biology field?
Yeah, so back in kind of, I guess, 2014 or so, there was a lot of excitement being generated for Cas9, which is the main CRISPR enzyme that people may have heard of for, cutting DNA and doing gene editing. And one of the things we were doing with Feng was trying to identify like how many CRISPR enzymes are there. So if you go back to like molecular cloning, the way we actually manipulate DNA and do recombinant DNA right now, there's hundreds, if not thousands, of restriction enzymes, which are the enzymes that can cut DNA and allow you to manipulate them. But back, decades ago, there was only one or two, and it would become a whole postdoc project, 4 or 5 years to identify a new restriction enzyme and purify it. And so, and now there are hundreds and no one thinks about them and you just use them. And so we thought actually with CRISPR, it'd be similar. Everyone's focused on Cas9 right now, but there's probably dozens, if not hundreds of variants that we could find. And so we took on that journey to, mine hundreds of thousands of bacterial genomes and screen all sorts of different protein families and orthologs. And we found other ones, Cas12, Cas13, and so on. And one of these enzymes, Cas13, it was really interesting. We thought we'd be able to use it for gene editing and RNA editing. And it actually targeted RNA instead of DNA. But what turned out is when we started testing it, instead of cutting RNA precisely, what would happen is it would bind its target, it would cut it, but it would also cut everything else in solution. So it kind of like exploded and would just cut everything. And so we realized, that's not going to work for, therapeutics. If you put that in a human cell, it's just going to kill the cell. And so what we did realize is, maybe it could have another use. And at the time, actually, we were really disappointed. We were like, oh man, this is not going to be useful. I guess we'll publish an interesting biology finding. But after, going on to Michael's, question last, we brainstormed. They were like, well, could we think of something else that this could be useful for? And what we realized is if you had a system that could bind and recognize a very specific sequence of RNA and then activate and cleaved anything, if we put in that reaction a reporter that could become fluorescent upon being cleaved, what would happen is that enzyme would basically report on the presence of a viral signature. So for example, that enzyme was recognizing COVID-19 genome. You would basically bind the genome, it would cut, and then release fluorescence. And so from a unexpected finding, we basically went down the whole diagnostics path, and that's kind of where it came from.
Very cool.
So, yeah.
This is a very philosophical question, but this is from Ruby Rajab from Saudi Arabia.
As kids, we would always ask questions such as, why did this happen? How and who? And demand answers for fulfillment. But I realize as we get older, many people lose that sense of curiosity and innovation. My question is, what was the thing that kept yours? Thank you.
Who wants to take that?
I'll take it.
Okay.
So, well, when I hear what she's saying, it really makes me think of sort of this project I had in, I guess, undergrad and grad school to kind of be able to, I did math, and I wanted to be able to, at any point in time, be given a proposition and be able to prove it down to like the axiomatic foundations of math. And I thought this was like a very interesting project, just an intellectual project of just being able to sort of know the foundations of knowledge, right, and be able to regurgitate them any time. And I think that that instinct has been helpful, because when I sort of in business, when I sort of go in and I'll look at a field, you'll sort of look at it and you'll say, like, why is this market set up this way? Why are the participants interacting this way? What are their incentives? And what you find is that oftentimes the participants themselves don't really know. And they sort of give you these not very satisfying answers of, oh, this is the way it is. This is just the way healthcare is, or whatever. And I find that those are actually oftentimes the best times to probe. And maybe it's the person in front of you doesn't know, but somebody knows, somebody can give you an answer. And that actually often unlocks some sort of insight about how you can approach this market. So I actually think that kind of intellectual curiosity is extremely important. As I think she alluded to, a lot of people will try to shut it down, perhaps because they don't actually know themselves and they don't want their sort of those assumptions kind of questioned. But just keep on probing. It's actually a good exercise.
Okay, next question is from Hassam Ashur from Saudi Arabia.
Scientific discovery and innovation are heavily driven by big organizations. Would increasing government-funded research provide better and more direct innovation to real-world problems? Thank you.
I'm going to push that to Omar and then David.
As an academic researcher, I would definitely say more government funding would help. It's more competitive than ever, I guess, to get typical research grants, and especially in understudied fields, I think it becomes even harder. And I'll give an example of where government funding can really accelerate things. So for our COVID testing work, which we started basically January 2020, a lot of government funding options came online at the tune of like $1 billion to accelerate rapid testing for people. And that was really helpful to basically accelerate the commercialization of at-home testing, which is this crazy concept that is almost, kind of being realized. And so I think government funding can really do a lot.
How about you, David, from a Brazilian perspective?
So I'm going to push back a little bit on that question, on the premise of that question. I think a lot of the innovation comes from people's needs and not corporate needs. I think the corporate world utilizes a lot of this innovation, but ultimately it comes from real world problems that people have, and you always want to solve that. I think government is very good or complementary to solving very long-term problems, because these problems, it's very hard for an entrepreneur to think of a 50-year-long problem. And so, solving something that is going to be, in the next 5 years is already big. 50 is too big. And then you need projects that don't need to, you need money that doesn't need to see results really quickly. And so basic science, for example. But I think non-government, so private, is also very important. And that's actually what we lack in developing countries a lot of the time. It's the critical mass of private companies and capital to drive innovation. And that's one thing that the US has in abundance.
The government is very good at really funding fundamental research, right? And fundamental research breeds applied, right? Translational work, but governments need to do more on both sides all over the world, not only in the United States, but Brazil, India, South Africa, Ghana, everywhere. Eden, question for you from Sarah Makel in Luxembourg.
As future entrepreneurs, how do we factor sustainability and environmental concerns into our vision of innovation? And furthermore, how do we include these issues in our model of entrepreneurship?
I think it's always important to build a business while valuing social impact and valuing the environment as you build your business. Fundamentally, don't start out building a business that's harmful for the world. But I also think in the early days, when you're trying to build product market fit, especially if you're building a company that doesn't directly connect to social good, that there's no shame in that, right? Mobot what we're doing is we test products for all sorts of industries that impact other folks, but fundamentally we make robots. That's not something that's going to impact the environment. But what we can do is when we as an engineering team are trying to make decisions about the power consumption of the robot, how many robots are being arranged in which way, how do we optimize usage of electricity, those are all small considerations that if we build the company with the right fundamental values from day one, you can then in little ways day to day build in those values. And I think that's going to be easier than trying to proclaim that 10% of profits go to some nonprofit startup doesn't have any profits at the beginning. So I think it's the little day-to-day actions that matter, and it comes from leadership. It comes from the top. So as the founder, as the CEO, it is my responsibility to make sure that other members of our team understand that that's important and that it's okay to speak up about their values.
Anybody else want to take this on in terms of sustainability and environmental considerations? This is a big deal now in entrepreneurship and founding of companies, right? Is the whole sustainability piece. Anyone else?
Yeah, I'm happy to talk about it. And I'll sort of broaden it out from more than just sustainability, but DEI, increasing opportunities for people who are underserved. Look, these are concerns that are near and dear to my heart and things that I find are incredibly important. And while the company I started doesn't directly necessarily impact this issue, I've actually found, I've just made a pledge that I will donate 10% of all proceeds to supporting various causes that I really feel strongly about. And I've sort of been donating to a lot of them, whether that be the local science fair back in Portland, where I grew up, or an organization called America Needs You, which helps first-generation low-income college students make that transition from college into kind of white-collar professional jobs, or the Center for Policing Equity, which is helping rethink how we do policing here in the U.S. These are all sort of organizations that I've been a part of, that I support financially and as a board member. And I really, this is just an important part of my life. And I hope if you're thinking about how you can give back, that you make that an important part of your life as well.
Okay, so we're getting to the end of this extraordinary conversation. So I'm going to end with a question. What is your advice to finalists, just very quickly? They're going out into the world now. Some are going to, I find them all to be winners. Getting to ISEF's a big, huge deal. But any parting advice, David?
I think Eden touched this already, which is it's okay to change your mind. You're not defined by what you just did. It's great, but you will change your mind many times and pivot many times in your life, and that's good. And you're going to find something that really motivates you for a long time.
Omar?
I would probably say, follow your gut. I think it can be hard, you come from ISEF, you go enter college and it's like, what do I do? And then after college, it's like, what do I do next? And, and then you have your career and it's like, where do you take that? And I think there's a lot of key decision points that seem like these big moments where it's like, what am I going to do? My last one is like, do I go back to med school or not? We touched on that earlier in the thing. And I think we build them up in our heads, but I think, at the end of the day, just, you should just follow your gut instinct. It'll know what you should do, and don't look back and just keep going.
How about you, Michael?
I think this is a great opportunity to meet folks from around the world. I remember senior year of high school, both at ISEF and STS, which is another program that Maya runs. I met so many bright, smart, really driven folks who in the sciences who've actually still are today some of my closest friends. We still can hang out, we still connect, and they're just a wonderful network to tap into, even 2 decades out from ISEF.
And Eden?
There's no one path to success. It might be going to college. It might be dropping out of college. It might be getting a PhD. It might be starting a nonprofit or a for-profit company. There are so many opportunities out there. Stay true to yourself and don't do what others think is the right thing for you. You have to be doing the right thing for yourself.
Well, thank you to David, Omar, Eden, and Michael. This has been a fabulous conversation. Thank you for everything that you do to make the world a better place. Thank you.